Welcome to this exercise where I'm going to explain how to solve logarithmic equations. What do I mean by this? Well, a logarithmic equation is something like this, where the x is part of a logarithm. So our task here would be to solve this equation we have here for the variable x. Well, how to go solving logarithmic equations? Quite often, in the first step, we can simplify this a little bit. And that's also the case in this situation. If we take a look here, we can actually apply one rule for the logarithm on the left side of the equation. And the rule I'm thinking of is logarithm of a divided by b is the same as logarithm of a minus logarithm of b. So in our case, logarithm of 1 minus logarithm of 1 plus x. And well, logarithm of 1, that's just 0. So we can write it as this, skipping the 0 in front of this here. This already simplifies the equation quite something, but we should get rid of this fraction on the right-hand side as well. Well, how to get rid of a fraction? Well, we can simply multiply with the denominator of the fraction. Here we have the added benefit that on the left-hand side I have exactly the same term. So if I multiply the equation with the denominator, on the right side I simply have minus 1, and on the left side the logarithmic expression is just squared. Well, so far so good. So the next step to get closer to the x, which now is only on one side of the equation, would be to get rid of the minus. So I'm going to multiply the whole equation with minus 1. And then the next step, well, I want to get to the x, so I have to work my way from the outside to the inside. So the next step would be get rid of the square we have here. Well, how to get rid of this? Well, I can take the square root, which would get rid of this. But if I take the square root of 1, I have to consider two cases. The case that the result is 1, or the case that the result is minus 1. Well, in both cases, I do not care, because I would do exactly the same thing. Since I want to get to the x, I have to get rid of the natural logarithm here. So I take the inverse function of the natural logarithm, which is the exponential function, and I apply this on both equations, left and right. So the first looks like this, and the second will look like this. Again, in both equations on the left side, there's the exponential function applied on logarithm, so both of them will cancel each other out, and we simply have those expressions on the left. And well, exponential function of 1 is nothing else than the number e to the power of 1. And here, exponential function of minus 1 is simply number e to the power of minus 1. So I can write it like this in a shorter version as well. Well, how to get to the x? I simply have to subtract those ones in front of the x here, giving me those two results for my equation. In this case, I just get roughly 1.7 and here roughly minus 0.63. Well, so far so good, but I have a logarithmic equation and I'm not allowed to insert into any logarithm 0 or any negative values. So I have to check if those two values are actually valid, so if I can insert them into this equation without generating an error. Well, if I insert the first value, I get in the denominator 1 plus 1.7, 2 point something, 2.7 something, or more or less e here. This is positive. Here the same thing, logarithm, natural logarithm of e. I can do this. So this is actually a valid solution. Then I have to insert minus 0.6321. Here then I have 1 minus 0.63. Well, it's 0 point something, but it's still positive, and something positive divided by something positive is still positive. Same thing goes here. Logarithm of 0.3 something is still positive, so I can calculate the logarithm. So both of them are valid with regard to the logarithm, but I also have a fraction here. Well, I already argued that the result down here will be positive. Since I'm not allowed to have a denominator of 0, they're positive, they're not 0, so even the fraction doesn't matter in this regard. Both are feasible with regard to the original equation. So I have two valid feasible solutions to my original equation. This then concludes this exercise. So I say goodbye and see you next time.